in lesson 104, we're going to look at writing complex numbers as, or rational numbers as integers. Now let's define a couple of things. A rational number, okay, what's a rational number? Okay, a rational number, I'll just read the definition, is if the digits in a decimal number terminate. Okay, it's a rational number. So 3.1728. All right, it's an example of a. And I'm sorry, the glare's in the way, but that's an example of a rational number. Any number with repeating decimals, so 2.523, and the 3 is repeating. That's a rational number. Compared to an irrational number would be something where it goes on and on. There's no end, in a sense. So pi, that would be an irrational number. Square root of 2 is actually an irrational number. And what, so rational numbers cover basically any number possible that we can have where the number terminates, or we know what the repetition is. Pi, there's no repetition. It just keeps going and in some weird mixed order that I don't even fully understand there. But example 1, let's look at a problem of how we're going to use this stuff. It says show that 0.00314 is a rational number, so we want to prove that it's rational by writing it as a fraction of integers. For all rational numbers, you can prove that they are rational by writing them as a fraction of integers. Integers, okay, that is -1, 0, 1, 2, -2, whatever, 3, any of those. Anything with a denominator of 1. That would be, and no decimals in the numerator. Those are integers. So we want to write this rational number, so I'm going to put in, we want to write this rational number as a fraction of integers. So here's our number. Sorry. Here's our number, 0.00314, and I want to write it as a fraction of integers. Well, what I'm going to want to do, since I'm writing it as a fraction, I can't just move the decimal. That'd just be writing it as a separate number. I want to keep it at the number that we have. So the fraction of integers, what we're going to want to do is see how many times do we have to multiply, or what do we have to multiply by to get this decimal to this spot, get it at the end. Well, this moves 5 times to the right. So what we want to do is actually multiply it by 10 to the 5th power. But since we are wanting to keep it the same, okay, since we're wanting to keep it the same number, we need to multiply by 10 to the 5th power over 10 to the 5th power. So watch what happens. I'll move it all the way over here because of the glare. When we multiply by 10 to the 5th power, we get 314 on top. And then on the bottom we get 100,000 because we have 5 zeros. So this would be how we write this number as a rational number written as a fraction of integers. So that's all that's what you're looking to do in those scenarios. So those ones are easier where it's products. It gets a little more tricky when we use repeating numbers. So let's talk about writing rational numbers that have repeating numbers as a fraction of integers. Okay, we're going to kind of look at this in steps. The first step is I want to go ahead and write down this number in what we call expanded form. The expanded form would be 0.016. Now with the 2, 3, between every 2, 3, I'm going to kind of put a little bar in between them. Okay? I'm going to put a little bar in between them. Sorry, that one. Because it goes on and on and on. All right? So dot, dot, dot. That is me writing this number as in expanded form. The next step is I want to look at how many numbers were being repeated. Okay, we had, in this case, 2 numbers being repeated. So what I'm going to do is multiply my number times 100. Because what I want to do is be able to move that decimal twice. So my new number on top that I get would be 1.6, and I want to write my repeating numbers just one time. So notice, the reason that I multiplied it by 100, yes, there's 2 spots here, but in the end, I am stacked evenly on top of my expanded number decimal. So we multiply by 100, and yes, the 2 3s continue on and on and on still. But what happens is from this point, we are actually going to solve these 2 equations. So imagine that they're stacked. Well, what happens is we are going to be subtracting. We're going to find the difference of these 2. So when we subtract 100n minus n, we get 99n. When we subtract here, we would get 706. Okay, 1.607. And then all these would end up canceling out because those would all cancel to be 0. So now from this point, I want to divide by 99. So I'm going to rewrite this over here. Now I'm at 1.607 over 99. So we've solved for n, and we're close. The last thing we have to do, remember we're writing this as a fraction of integers, so we can't have the decimal. So what we need to do is move the decimal 3 times to rewrite it as a fraction of integers. So this would be your rational repeating number as a fraction of integers. So step 1, write it as expanded form. Step 2, multiply whatever the power, 10, 100, 1,000, by how many repeating numbers you had, rewrite it on top, stack it, and then you're basically solving. So it's kind of a weird form, but that is ultimately how you write the repeating digits as a fraction of integers.